In the final video of this series, I'll be discussing how work, power, and energy can be applied to the fly fishing cast, with work defined as force times displacement times the cosine of theta. This is applicable to fly casting, as there's a certain amount of movement that needs to occur in order to get the line going and to deliver the fly to the fish. The hand of the fisherman must be moved backwards in order to move the rod and turn the line. An initial force is applied roughly perpendicular to the rod. This causes the linear displacement that moves the rod to the back of the motion. Then, a force is applied directly opposite to the momentum of the fly rod in order to reverse its direction and send the line forward. It is important that this force be applied directly opposite to the momentum of the rod in order to send the fly where the fisherman intends. A deviation from this desired angle will result in inaccurate and ineffective casting. This is the work that is being done. The rate at which this work is done is also an important factor. Power is defined as work over time, which means that the faster force is applied, the more power will result. Work will remain the same since there's not a change in the amount of force generated or the amount that needs to be done, but rather the interval over which it is applied. Casting too slowly will result in a loss of power, which will in turn prevent the line from flying behind the fisherman properly. One of the biggest concerns that new casters have is that they will catch themselves with the fly. This can be avoided by applying a proper amount of power to the rod, which will in turn keep tension on the line, which will keep it flying away from the fisherman and where it needs to be. Potential energy is readily apparent in the fly casting motion when looking at the fly rod and the bend that it forms. A larger bend results in more stored potential energy, which can be released into the line when the hand stops at the front and the back of the cast. A movement with a high amount of power will cause a greater bend in the rod, which will in turn cause it to store more potential energy. When the hand stops, all of the energy that is stored in the rod quickly becomes kinetic energy as it is released. This propels the line through the air to the intended target. The more potential energy that the fisherman can store in the rod during the movement phase of the cast, the farther he will be able to cast. The faster the hand stops, the larger the amount of potential energy that is released into the line as the rod straightens. This is why it is important that the hand comes to an abrupt stop. Many new fly casters make the mistake of not stopping quickly enough, and this reduces the amount of energy that they are able to transfer into the line. This is analogous to hitting a target with a ball. If the target is soft, the ball will decelerate more slowly, releasing its energy more slowly, and it has the potential to do so over a small range of vectors. Whereas, if a ball is thrown at a brick wall, it will be forced to release all of its energy in one moment along a single vector. Different fly rods are built to bend in different ways in order to better facilitate this release of energy. In addition to this, there are many types of fly line that have different weight distributions in order to further accommodate it. While this movement does not include collisions with any objects, the fly rod behaves in a similar manner as was just discussed.